Hello everyone. For our semester term project, we have worked on the decentralized backup of logging data in cloud applications using IPFS. I'm Zinara Khan and I'll be talking about the introduction research objectives. My group members, Tariq bin Shams, will talk about the literature review and proposed methodology, and Mahid Atif will continue with the proposed methodology, conclusion, limitations, and future works. This is the outline according to which we have written our paper. Now, first to begin with, why IPFS and logging system? So initially there is an SOX law which states that financial institutions have to keep a trustworthy log of their IT-based activities. This is where we propose an IPFS, which is an interplanetary file system, which will allow for the creation of a decentralized file system through a peer-to-peer network. It makes a reliable, secure method of storing and sharing data, which can be used without having a central authority or trust between nodes. So we also use IPNS, which is built on top of the IPFS system. It is a distributed naming system which allows users to create and manage their own namespace so that when they're assigned a name for a specific content hash, they can use it to create human readable names rather than just using the contents hash. And we have used AES, which is the Advanced Encryption Standard Symmetric Encryption Algorithm, and it can support a size of 128, 192, or 256 bits. The research objectives of our paper was to develop a cloud backup solution for logging data, which will help to reduce information abuse, hacking, fraud, and other financial crimes. Using the RSA 256-bit encryption algorithm, this will minimize the burden of complying with regulations when we are handling client-sensitive information. Now moving on to our next member. Thank you.
Hello, I am Tariq bin Shams. I will discuss the literature review and methodology of our paper. One publication discusses cloud-based logging data backup, a way for preventing manipulation and ensuring cloud forensics privacy. This method verifies process records. The suggested architecture incorporates a Merkle root for issuing blockchain receipts to validate data. Uh, A paper offered a method for breaking the 9-round version of the AES-256 encryption algorithm in which complete 256-bit key may be identified in 239 by simply employing the most basic form of related keys. Another paper introduced blockchain technologies, blockchain transactions to trace and verify cloud data origination. The architecture uses OwnCloud to acquire origin information. ProfChain uses blockchain technology to record the history and origin of cloud stored data while prioritizing user privacy and data availability. The authors of an article suggest a game theory based framework to model cyber threat information in public cloud computing. The game theoretic model reflects trade-offs between public cloud, user security, and cyber threat sharing. Now, the proposed methodology. mm, I am discussing the IPFS cluster in our proposed methodology part. So, in IPFS cluster, we use Docker. So, Docker Compose was used to create three IPFS cluster, each with a single node. Docker enables us to develop and deploy IPFS nodes and cluster independent of cloud providers. We set replication to maximal since we want our data on all nodes. The nodes are secured with secret keys and to prevent them from connecting to the internet. We have pinned all CICDs so that thresh controller cannot destroy data without authorization. Using external IPFS nodes would mean we lost intercontrol over the data, even though the data is encrypted. IPFS can manage significantly larger file in the cloud since it transforms the data into a smaller fragment. Public IPFS nodes do not have complete control over the replication factor. Hence, most are not replicated efficiently. The private nodes can be deployed among several cloud providers for optimum reliability and availability. Using Docker Compose, we can spin up the cluster containers and nodes. Each cluster nodes are separate. The cluster is the control plane for the nodes underneath it. Then the IPS client application. In this will present by my teammate Mahit. That's all my presentation. Thank you.
Thank you. I'm Mahit Atif Hussain, and now I would like to talk about the implementation of the IPFS client application. The client application is basically the user, or it can be a part of a container as a sidecar. So, for the main backend, we have chosen Node.js as it's a very popular runtime and it is very easy to implement our prototype in it. And it also supports all of the modules necessary for the implementation. Here we have used the native IPFS module, and included with the IPFS module is a tool called MFS, or Mutable File System. It allows us to treat any file on the local system and upload it to IPFS. And from there we can treat that file as it's a local file system. We will be able to change, edit, move, delete any file on the IPFS as if it's a file on the local system. So we have used it to upload the logging file to the IPFS network, and before uploading it we have used AES 256-bit encryption to encrypt our data. By using that, we can ensure that any bad actor can get our data, but they will never be able to decrypt our data without the secret key. After we have uploaded the data, we will get a corresponding CID, or a content identifier, for that data. This is basically like a hash. This hash will change every time we change our file, or even if we rename our file. So after we update our logging data file, we will receive the CID and we will push this CID into our IPNS node, or the Interplanetary Naming System node. This this node basically gives us the ability to attach a mutable pointer to this immutable CID, or a content identifier. By using this, we can ensure that if any changes are made to the IPFS node, then we will be able to verify if it is the correct one or not, just by comparing it to the IPNS corresponding CID. Now we will take a look at the system architecture. Here we can see that this container user is basically the data aggregator, or any application that produces any data. This application, or the IPFS client application, will push the logging data to our IPFS cluster, our private cluster, and then we will get a corresponding CID. This CID will then be pushed to the IPNS node, and then it will be mapped to a human readable name, which is basically like a DNS record. Now let's look at the conclusions. By doing some local testing, we have found out that this whole system depends largely on the hardware, on the network bandwidth, and the type of storage used. But we have a huge limitation, which is that we did not have access to cloud infrastructure like AWS or GCP. So we were not able to give any real world data, or any data which involves the cloud. But we plan on implementing this whole system in Golang, because it is much more efficient and it can be converted into binary data as well. And it also has less overhead compared to Node.js. We also plan on orchestrating the whole system using Kubernetes, which will allow us to easily deploy our cluster on multiple cloud providers with less overhead. So thank you so much for your time. I hope you liked it. Thank you.